Imagine for a moment that you're looking at the night sky and seeing an ordinary star, like our sun. Now, what if I told you that hidden within that same cosmos are stars so exotic they defy everything we know about matter? Stars made of particles we can't even create on Earth, so dense that a grain of sand from them would weigh more than an elephant, and so strange that they might be rewriting the laws of physics right before our eyes. Today, we're going to dive into the universe of the most bizarre and fascinating stars science has ever imagined: quark stars, preon stars, and even boson stars. Get ready to discover how these impossible cosmic entities might be hiding in the universe, disguised as ordinary stars, and how their existence could revolutionize our understanding of the very nature of reality. Hello, cosmic explorers. Welcome back to Cosmic Frontiers, where we unravel the deepest mysteries of the universe. We're on an incredible journey towards our first 1,000 explorers, and today we're going to explore a cosmic territory where physics meets science fiction. Let's begin our journey by understanding what makes a star truly exotic. When we think of stars, our minds go straight to the sun, a gigantic ball of gas where hydrogen nuclei fuse to form helium, releasing the energy that illuminates our solar system. But the universe is far more creative than that. Under extreme conditions, when matter is compressed beyond any imaginable limit, it can transform into states so exotic they seem straight out of a science fiction movie. To understand these impossible stars, we first need to talk about density. Imagine taking the entire population of Earth, about 8 billion people, and compressing them into the space of a pinhead. That would still be less dense than the matter inside a common neutron star. Now, the exotic stars we're going to explore today are even denser and stranger than that. The first stop on our cosmic journey is quark stars, also known as strange stars. To understand what they are, let's take a trip to the subatomic world. Imagine you're disassembling an atom like a Lego toy. First, you remove the electrons. Then, you break the nucleus and find protons and neutrons. But the story doesn't stop there. If you could break the protons and neutrons themselves, you'd find even smaller particles called quarks. Under normal conditions, quarks never exist alone. They're always stuck together in groups of 2 or 3, forming the particles we know. It's as if they were extremely shy people who never leave home alone. But in a quark star, the pressure is so intense that this fundamental rule of nature can be broken. The quarks are released from their subatomic prisons and form a cosmic soup of free matter. Edward Witten, one of the world's most respected theoretical physicists, proposed in 1984 that these strange stars could exist. According to his theory, when a massive star collapses, instead of forming a traditional neutron star, it could create something even more exotic, a star where matter exists in a completely new state, a soup of free quarks. The difference between a neutron star and a quark star is like the difference between an organized library and the same library after an earthquake. In a neutron star, the particles still maintain some structure. In a quark star, everything dissolves into its most fundamental components, creating a cosmic ocean of pure matter. But the universe can be even more creative. Let's now explore an even more exotic territory: preon stars. If quarks are the fundamental building blocks of matter, preons would be the atoms of those building blocks. This is a purely theoretical idea, proposed by some physicists who believe that even quarks might be made of even smaller particles. Imagine you're looking at an impressionist painting from afar. You see defined shapes and colors, but when you get closer, you realize that everything is made of tiny dots of paint. Now imagine that each of those dots is, in fact, made of even smaller dots, invisible to the naked eye. That's the idea behind preons, hypothetical particles that would form the quarks themselves. A preon star would be an object so dense and exotic that it would challenge our current understanding of physics. If quarks are already difficult to imagine, preons are on a completely different level of cosmic strangeness. These stars would be natural laboratories, where the very fundamental structure of reality would be tested to its limits. But the journey to the impossible doesn't stop there. Let's now explore the most bizarre concept of all: boson stars. To understand this, we need to talk about one of the most important discoveries in modern physics, the Higgs boson. In 2012, scientists at CERN announced the discovery of the Higgs boson, a particle that gives mass to all other particles in the universe. It's as if it were an invisible field that permeates the entire cosmos, and particles gain mass by interacting with this field. Imagine you're walking through a pool full of honey. The more you interact with the honey, the harder it becomes to move. The Higgs field works similarly for subatomic particles. Now, some theoretical physicists speculate about the possibility of stars made entirely of bosons. These would be cosmic structures where the very force that gives mass to the universe would concentrate into stellar objects. A boson star would be like a knot in the fabric of reality, a place where the fundamental rules governing mass and energy would manifest in a pure and concentrated form. Theoretical physicist Juan Maldacena and his colleagues have mathematically explored how these exotic stars could form and behave. According to their theories, a boson star would be stable in a completely different way than normal stars. Instead of being held together by nuclear fusion, it would be sustained by the quantum properties of the bosons themselves. But here comes the question that intrigues every cosmic explorer. Do these impossible stars really exist? And if they do, why have we never seen them? The answer might lie in the exotic nature of these objects themselves. A quark star, for example, could be almost indistinguishable from a common neutron star when observed from afar. Imagine you're trying to distinguish between two identical cars, but one of them has a completely different engine. From the outside, they look the same, but inside they are fundamentally distinct. Some astronomers believe that we have already observed indirect evidence of these exotic stars. There are objects in the cosmos that behave strangely, emitting radiation in patterns that we cannot fully explain with our current understanding of neutron stars. These might be our first glimpses of the impossible stars. The gravitational wave observatory, LIGO, which revolutionized astronomy by detecting ripples in spacetime itself, might be our best tool for identifying these exotic stars. When two quark stars collide, they produce gravitational waves with a unique signature, different from collisions between normal neutron stars. It's like distinguishing between the sound of two violins and the sound of two pianos. Both make music, but with distinct characteristics. The search for these exotic stars is not just a scientific curiosity. Their discovery could revolutionize our understanding of the fundamental nature of matter and energy. If we can confirm the existence of a quark star, we will be directly observing a state of matter that we can never replicate on Earth. It would be like having a cosmic laboratory where the laws of physics are tested under conditions impossible to reproduce. Imagine the implications for future technology. If we understand how matter behaves in these exotic states, we could develop materials with unimaginable properties, materials more resistant than anything we know, or forms of energy more efficient than any current technology. But perhaps the most fascinating aspect of these exotic stars is what they tell us about the creativity of the universe. In a cosmos where matter can exist in such bizarre and impossible states, what other surprises await us? What other secrets are hidden in the depths of space, disguised as ordinary objects? With each new discovery, we realize that the universe is far stranger and more wonderful than we ever imagined. The stars we see in the night sky may seem like distant and simple points of light, but some of them might be cosmic laboratories, where reality itself is shaped and tested. Recapping our cosmic journey today, we explored quark stars, where matter exists as a soup of free fundamental particles. We discovered preon stars, hypothetical objects made of the smallest imaginable particles, and we delved into the concept of boson stars, where the force that gives mass to the universe concentrates into stellar objects. Each of these possibilities represents a natural laboratory where the laws of physics are pushed to the absolute extreme. When we look at the night sky, we are not just observing distant points of light. We are contemplating a universe where matter can exist in states so exotic that they challenge our imagination. Perhaps, at this very moment, a quark star is shining in some distant corner of the cosmos, guarding secrets about the fundamental nature of reality. And perhaps, with advances in science and technology, we may soon not only detect these impossible stars, but also understand the profound mysteries they hold about the universe we live in. Cosmic explorers, what do you find more fascinating? The possibility that these exotic stars already exist hidden in the cosmos, or the fact that there is still so much for us to discover about the fundamental states of matter? Leave your thoughts in the comments. And since we're talking about cosmic mysteries, what enigma of the universe do you want me to talk about in the next video? Primordial black holes, dark energy, or perhaps something about extraterrestrial life? Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers. If this video sparked your curiosity about the universe, Join our crew by clicking subscribe. Like this video if it expanded your cosmic horizons, and share it with someone who also loves the mysteries of the universe. In the next video, we'll explore another fascinating territory of the cosmos that promises to further expand our understanding of reality. Until then, keep looking at the stars and wondering what secrets they hide.